Okay, so those are some examples of denial of service attacks that have been seen in the wild. So I kind of want to walk you through systematically denial of service both on hosts and on networks. So let's start with denial of service on end hosts. One broad category of way to try to mount a denial of service attack on a computer is to try to find some flaw in a program that's running there and then trigger that flaw, that bug, something that will find some bug that causes a server to crash. Like maybe you can cause it to dereference a null pointer or something like that. Okay, so that's one approach, is you're exploiting a program bug. A second broad kind of approach is nothing to do with any bug in the server on that machine, but just to exhaust the resources, overwhelm it. So you might exhaust the network so that its network connection is full and it can't handle any more network traffic. You might overwhelm its CPU. You might cause the program to enter an infinite loop or run another process on the same machine that consumes all available CPU, and then it can't get any useful work done. You might overwhelm it by exhausting the amount of available memory or the amount of disk space or any finite resource. If you can find a way to exhaust that resource on the server, then you may be able to prevent that server from getting any useful work done. Those are host level attacks. At the network level, we'll see some network level attacks. So there are some attacks that involve attacking the network and overwhelming the network. And I want to draw a distinction between that and application level denial of service. So rather than overwhelming the network, we could overwhelm the applications that are running on the end host. So let's start with application level. And I've been speaking a lot, so I want to get you thinking now. Let's imagine that you can log into a multi-user Unix system. Like, for instance, instructional servers, Cori.except.berkeley.edu, or a Hive machine. And suppose you were malicious. Please, I'm asking you not to do this, but suppose you wanted to mount a denial of service attack that prevented all the other students from using those servers. What could you do? Think about it and type in chat some things that you could do to disrupt other users on that same system. Yeah, good. Let me write down some of this stuff that I'm seeing. This is great. SSH into all the hives. Yeah. So what are you trying to do? You're trying to log into many machines. Okay. Overwhelm the ports. Yeah, open lots of connections maybe. If there's a limit on the number of ports that can be open or the number of connections that a machine can have open, you could try to open lots of those. Take up all the resources. Yeah. Start a lot of processes. Excellent. Start lots of processes. Yeah. You could just do what's called a fork bomb. So in a fork bomb, what you do is you enter an infinite loop where each iteration of the loop, you start a new process. Cool. Open Photoshop? Aha, I love it. Why Photoshop? Because that probably takes up a lot of memory and a lot of CPU. Okay, and we could go even further. We could take up a lot of CPU. We could like run a program that takes up a lot of CPU. We could write our own program that we know how to write programs. So we could write our own program that uses a lot of CPU. Maybe enters an infinite loop or starts doing Bitcoin mining or something like that. Good. Find an input that causes the system to crash. Okay, we could look for an input that causes something critical to crash. Okay, makes sense to me. Running a bunch of programs, as many connections as possible. Yup. Run 189 homework 6. Oh boy, I don't know what homework 6 was, but I'll take your word on it. Okay, good stuff. Anything more I'm missing? Use up all the storage. Yeah. How would you use up all the storage? Create a lot of files. Yeah, create a lot of files with random data. Like you could create lots of temporary files. You can create files in /temp and you write lots and lots of them and write lots of data in there. And wait until you try to, use up all available disk space on the machine. Okay, RM minus RF star. I like that. Okay, that's interesting. Well, if you do that from your home directory, you'll only be deleting your own files. You won't affect anyone else. So maybe that's not the way to go, but you could imagine doing something like this from the root directory. Although maybe that's not the way to go either, because you would need root level access and you probably won't get very far if you do that. But you could imagine trying to do something like that. If there are any shared files, you could try to delete them. Okay, so I'm going to put a question mark next to this. This needs like a sysadmin access. And if you have sysadmin access, you can maybe like kill everyone else's programs. Okay, that's good. That's lots of good ideas there. I thought what I would do now is I would show you what I came up with before lecture, and we can compare to what you got. Write lots of files, gobble up all the disk space. I got that. Create a zillion processes. Yeah, you can do that in a one-liner in the C program, or even a one-liner in the shell. Create zillions of files, keep opening, reading, writing. Yeah, okay. Create zillions of files. We've got that. Another thing you could do is you could, that we didn't quite get so far, would be open a file and read and write it a lot, and then just keep doing reading and writing and reading and writing, and that will, rather than using up all available disk space, the purpose of that would be to use up the bandwidth to the disk. So the disk is spending all its time reading and writing your file or your files, and not actually doing anything useful. Okay.